Hey mathematicians, it's Mrs. Post here. Today we're going to work on factoring quadratics, and I have some notes here and I want you guys to write down everything I write. So you will have a copy of this in today's assignment in Schoology, and I want you guys to make sure you have every single example I have and also every step I have. So what we're doing today is, like it says up top, rewriting quadratics into factored form. And I think the biggest piece, the biggest takeaway today is for you guys to think about, why are we doing this? Why? What is the reason? So the reason is we're going to write quadratics into factored form so we can start solving them for x. So factoring is one strategy to solve for x, because isn't that really what we do in algebra? We just solve for x, right? And so we're going to start doing that tomorrow. But right now, let's just go ahead and get them in factored form, and then we can start solving them from there. Okay, so that's our mission for today. So just as a reminder, if you don't have these written down, write it down, these forms. So standard form is always a plus b plus c, right? Ax plus bx plus c. But if it's a quadratic, then it's ax squared plus bx plus c. And so remember, if it's an equation, we just use y equals. If it's a function, we use f of x equals. Okay, so just a couple of reminders here. So if we call it a quadratic function, it's just how it's written with f of x. If it's an equation, we just write it with y. Factored form here is y equals x minus r1 times x minus r2. And so right here I wrote that r1 means the first root or solution, and r2 means the second root or solution. So that's what r1 and r2 mean. And once again, if it's a function, we write f of x instead of y, but it just means the same thing. I don't want you guys to be confused about that. So we're going to go ahead and do a few examples, but before we do that, I grabbed this picture from Edgenuity, so you guys can take a look at different types of factoring. That should be a review for you. These are Algebra 1. This is the Algebra 1 topic. When we get into solving them, that's the Algebra 2 part, but this part is the review. What I'm going over today is also a review. So right here, this first example here, 16x squared minus 8x plus 1. That's a perfect square trinomial, and you might remember that from Algebra 1, hopefully. And the second example here, 9x squared minus 49, that's what we call a difference of two squares. You might also remember that from Algebra 1. Those are just patterns. I'm not even going to go over that in detail. I will give you the patterns later once we put this all together, but right now just know that if it's set up in these particular formats, then all you have to do is rewrite them in that particular format. Let me see if I can grab my draw tool just to make a couple notes for you guys. I would still write these down today just so you have them. So like this is a perfect square trinomial. And that's the pattern right there, and you can factor it like this, okay? And then same over here, this right here is a difference of two squares, because 9x squared is a perfect square, and 49 is a perfect square, because the square root of 49 is 7, the square root of 9x squared is 3x, difference of two squares. So if they're set up in these formats like this and like this, all you have to do is rewrite them into this cute little setup here. And that's it. Also, this third example down here, x squared minus x minus 30. This is what you might have called it like the AC method or something like that, but I'm just going to call this, honestly, normal factoring. So if you are struggling with this, you may struggle today, but you need to be aware of that. And then if you are, let me know and we can get you some more examples. But this is where if you look at it, it's x squared minus x minus 30. So you're trying to figure out, okay, if I was to have this in standard form, like ax squared plus bx plus c, it would be like this, right? Ax squared plus bx plus c. It's set up kind of like that, where my a is 1. And this is why it's considered normal factoring, because your a term is 1. That very first term in front of the x squared is 1. It's 1x squared. So if that's the case, these are very, very quick to do. They call it the AC method because they're like, what number can we get if we multiply the a term times the c term? 1 times negative 30 is negative 30. I'm going to change my color here. This should be a review for you guys. I'm just going to kind of see if this helps a little bit. We write it like 1 times negative 30 is negative 30. What can we multiply? What two numbers can we multiply to give us negative 30 but can add to give us a negative 1? Well, I'm thinking 5 and 6. 5 and 6 give us 30, but we need a negative 1 and we need it to multiply to give us a negative 30. So I'm thinking, what about if we make the 6 negative? And that's what happened here. You have a negative 6 times a positive 5, that's negative 30. You add them together, you get a negative 1, which is that middle term right there, the b term. That's normal factoring, okay? So we're going to use that today to add on. If you were looking at the Edgenuity lesson on factoring, this is where I pulled these examples from. Thought it was a nice little way to put all of these different methods together. This last one, 3x squared plus 17x minus 6. This is what we're going to do today. We're going to work on problems like this. They're not perfect squares. They're not difference of two squares. Let's see. They are not, a is not equal to 1. They're a little bit more complicated, and even on the Edgenuity lesson, he just kind of does guess and check and finds these numbers, but that's not going to be helpful to you. The reason why I hated factoring when I was in Algebra 1 in high school was because of problems like this and no strategy. It was very, very frustrating. So that's why I have a strategy for you guys. Okay, so the strategy I'm going to give you guys is called slide and divide. Slide and divide is a strategy that is basically going to work with any kind of quadratic that is factorable. If they're not factorable, we call it prime, if you remember. I'll write that down here. So that's always an option too, right? Sometimes you can't write them in factored form. Like the numbers just won't multiply to give you another number that needs to be added together. So like, for example, the negative 30, maybe you can't get negative 1 or something like that if that were the case. Remember, we call that prime. You just can't rewrite it in factor form. You can't get the numbers to work. So that's an option, but not today. We're not there yet. So anyway, just be on the lookout. But we're going to use a strategy called slide and divide. And so here are the steps. So you need to take a moment, you need to pause the video, and you have to write the steps down. So step 1, I'll go ahead and we'll look at this first one together, and you can write the steps down. But you need to make sure you have them in your notebook. And especially if you ask me for help or if you're in class and you're confused, I'm going to say go back to your steps. The steps are so important. I just want to reiterate because we're going to be using these, I want to say, at least to February, if not through February. We're going to factor for a long time, most of the school year. So this is so important, and you're going to really enjoy factoring so much because it's a step-based system. So you're going to do it so much, and it's going to be so fast for you that it's going to be faster than other strategies to solve quadratics. So I promise. I wouldn't say it if it were not true from my past experience with other students, okay? So make sure you do write the steps down. We're going to go ahead and take a look at this first one. I'm going to answer that one first. Okay, so step number 1 says factor out a GCF if possible. So here's our example. There is no GCF in this particular example. 6x squared plus 7x minus 49. 6, 7, 49, they don't have any numbers in common. They can't be divided by another number evenly, so there's no GCF here. All right, so we're going to keep going. You always want to check that step. If you don't check that step, it's not going to help you out later. Change my color real quick and try to use blue or something. Okay, so let's go ahead and keep going. So there's no GCF, so we're just going to keep on going. Always check. You got 6, 7, 49, no GCF. All right, step 2 says to slide A to C by multiplying. So you're going to take your A term. Remember, your A is 6, your B is 7, and your C is 49. Well, technically that's a negative 49, and then, yeah, that technically is a negative 49. Okay, slide A to C by multiplying. So take your A and slide it over to C by multiplying. So that means that's going to be x squared plus 7x. And now your C is going to be negative 49 times 6, because it says slide A to C. So negative 49 times 6 is going to be 294. So, well, negative 294. So now this is 294 here. It looks big, but it's going to be all right. So now it says we did that, and if you notice, our a is now 1. Our a term is now 1, right? Now it's 1x squared. So now we can factor normally. What's factored normally? That's what we were talking about up here. What numbers can multiply together to give you negative 294, but add to give you the middle term b, right? That's your b term right here. Okay, so let's go ahead and do that. So I'm going to go ahead and we're going to make a quick list. We're going to say, okay, if I have negative 294, what numbers give us negative 294? But they have to give us 7 when we add them together. So I know 1 times 294, that's not going to give me 7, right? And you're just going to keep going down the list. And you just use your calculator. Let me grab mine. And I just kind of try to stay consistent. I'm like, okay, 1 times 294. What about 2? So 294 divided by 2, that's going to give me 147. Okay, that's not going to give me 7. What about 294 divided by 3? That's going to give me 98. And I'm going to keep going because obviously I'm trying to get to 7 here, and these are nowhere near. If I add these together, I'm not going to get 7. I'm just going to keep going down. Okay, so I found it, 14 and 21. So if I multiply 14 and 21, I'm going to get 294. When I subtract 14 and 21, I'm going to get 7, which is exactly what we want. We need 7 to be positive, right? If you take a little look right here. So because that needs to be positive, that means I'm going to need my larger number to be positive, right? So I'm going to keep 21 positive and I'm going to make 14 a negative. So factor normally, okay, well this is factored form, right? X minus root 1. Doesn't matter what order. I'll put my negative 14 first and then my positive 21 second. There you go. So that's factored form, and that's all you're trying to do here. So we did step 3. So step 3, remember, you're just looking for numbers that multiply to give you the C, but add to give you the B, the number in the middle. Okay, divide your original A term by what you slid in step 2. So I'm just going to change my pen back. So it says divide your original A term by what you slid, divide by your original A term by what you slid in step 2. What did we slide? We slid this right here. We slid this. Oops. We slid 6 over. Remember that? So right here, we slid the 6 over here. So that means we're going to take x minus 14 and we're going to divide by 6. Why 6? Because that's what we slid in step 2. So now this is going to be x plus 21, and my 21 is also going to divide by 6. That's step 4. That's what that means. Okay, why 6? Because that's what we moved over to multiply. Simplify, can you simplify? You can. X minus 14 over 6, what can go into 14 and 6? 2, so it'll be 7 over 3. And then we've got x plus 21 over 6 here. So what can go into 21 and 6? It looks like we can simplify this one into 7 and 2 here. Let's see. Because 3 can go into 21 7 times, and 3 can go into 6 3 times. Okay, and now it says slide them up. Okay, so that step is done. If you don't do this here, then later you're going to have to look for a GCF and simplify it. So it's just easier to do step 5 there. That's why. All right, and lastly, it says slide them up. Slide the denominators in front of the x's. So now we're going to have 3x minus 7 and 2x plus 7 here. What did we do? Well, we took the denominators just like it said and we split them up. So we put the 2 right here and we put this 3 right here. And that's how you always get those coefficients in the front right here. And had we not simplified, or in step 4, you would have had 6x minus 14 and 6x plus 21. You would have needed to simplify here. So anyway, that's why we did that. So that is true factored form. Make sure you write all of these steps down into your notebook, okay?